Ladyada.
Everybody, and welcome to my desk. It's me, Lady Ada, doing some electronics. Went outside. It was a beautiful day today, and of course yesterday as well. I love that spring has sprung. Means it's also time for 8051s. That's a little rhyme there. I'm working on a cutie pie CH552P. So let's go to the overhead. I'll just show it off real fast in case people don't know the cutie pie format. So these are the cutie pie boards. It's based off of the Shao format that Seed came up with, which I just thought was so cute and adorable. And it's basically the same size as most of our Stomach QT boards, about almost, well, it's a little bit less than an inch by 0.7 inches. It's got like castellated pads, and it's got the same pins in this location. It's like a little micro feather kind of. It's got A0 through A3, so you need like 4 analog inputs, data clock for I2C, RX and TX for hardware UART, and then hardware SPI pins, S clock, MISO, MOSI, 3-volt ground and 5 volts. So it doesn't have battery charging, and it doesn't have like an exposed reset. But what I did to the Shao series was I added a STEMMA QT port kind of in this location always, and so it makes it like so easy to plug and play all sorts of sensors like this HT20, or like I've got a SGP30 here or whatever. And then there's like a little NeoPixel here, and then the chip here, like I said, is the CH552P. Just kind of like a change, because for recently what I've been doing is doing more and more complicated boards, like we had the ESP32S2 and S3 and the Pico, and we started with the SAMD21, which was a fairly, it's a Cortex M0 chip. I don't think we did any 8-bit cutie pies. I was thinking about maybe doing a 32U4 based one, but never quite finished it. But we do have here, like I said, this is an 8-bit microcontroller, an 8051 core, but it has native USB, and it's very inexpensive. It's like famous as like a 20 to 40 cent chip. The 25 cent version has 8 pins only, and that's like a chill too few. This one has it's a little bit less than I like pins, but it's still a fairly good number. Maybe let's go to the computer and I can show the schematic. So this is the chip, the CH552P. One cool thing about it has a built-in 3.3 volt regulator. I'm not using it in this case because I actually couldn't find any specs on how much current it provides. It's probably not more than like 50 or 100 milliamperes. And I really wanted to have like, our kind of standard 300, 500 milliamp power supply, because it's, I don't know. I mean, I could have done without, but I think if you were really make a very low cost board, you could skip it, and then you tie VCC to 5 volts, and then V33 is then your 3.3 volt regulator out. In this case, you tie them together, and then there's a my AP2212 over here, super low dropout regulator. Like I said, there's built-in native USB, which is pretty amazing for a 8051 core. But yeah, D plus, D minus. And the D plus pin is also used as the bootloader entry, and also has a USB bootloader. It doesn't use mass storage. It's not like UF2. And there's not enough space to implement UF2, and I don't even think it has enough RAM to do mass storage anyways. But the HID bootloader built in, it's like an HID, it's low level USB. And to get into bootloader mode, you tie the D plus pin high, and then you release it after a couple seconds or whatever, and then it will then re-enumerate into the bootloader mode for like 10 seconds, and then leave bootloader mode. There's PWMs. You see, I tried to label here all the pins with their capabilities. There's a couple analog inputs. Only thing that's a little annoying is that there's only 4 analog inputs. So they're labeled here. So this is like AN1, AN2, AN3, and AN0. So there's exactly 4 analog inputs, which is perfect because the Cutie Pie only has like 4 labeled analog input pins. But there's one pin gets shared. The MOSI pin is the same as the analog in pin. So there's one like shared pin on the Cutie Pie, which is like not ideal. But I really wanted to have the hardware peripherals on the hardware peripheral pins, and I wanted to have all the analog pins be analog pins. So like, this is the trade-off. And then One pin I took for the NeoPixel because this pin kind of has the fewest capabilities, really. Okay, and so there's one NeoPixel, and then there's an I2C output on that Stomach QT port. There's a the boot pin, and then there's also a reset pin. Note that the reset is inverted. You pull it high to reset. This is not, it didn't catch me, but it is backwards from like every other microcontroller, so watch out for that. And then the layout wasn't too hard. You know, it's single-sided. It's good here. And then I'll turn on the silk screen and then turn off the bottom. It's a 2-layer board, which is kind of nice. So USB Type-C, the 5.1 ohm resistors, a little protection diode just to, you know, give the 5-volt beam output only. Regulator section, NeoPixel. 2 buttons, one for reset, one for bootloader mode. Because again, you can't double click to reset. You have to do that D plus pulled high thing. The chip itself and the JST SH for the Stomach QT port. And it fits and it works fine. So I've been playing around with this chip and I'm using the CH552X Drino core written by Dicheng Sun, who worked on us a while ago on a bunch of Bluetooth projects. So it's cool to see that he's still doing a lot of stuff. He was at NYU ITP, I think. And so this is a MCS 8051 core USB. So what's nice about this is that this lets you use the Arduino IDE to write code for this 8051 core chip. One downside is that the compiler is a free compiler and does not support C++. It's a C-only compiler. So what happens is that you end up with, you know, this is what we would normally have for AHT chip, where you have like our library and you instantiate it, and then you like call like object.begin, and you have serial.println and like ... because you have object, and then you call the constructor or the member functions, or you know, access the member variables. Whereas for the CH552, well, something like digital write is pretty simple. Like, and then I have pins defined. There's no pin definition, so I had to like make a pound define list for all the pins. Because the pin numbers, you know, they don't get translated. There's no variant. But when you talked about something like I2C, there's no wire dot function. There's no wire object, and there isn't even like really wire. You know, the I2C interface is very, very low level. So for example, I had to write a function called write bytes that would take an array and it would like do the acking and knacking, and it's like it does all the work. It has an I2C hardware peripheral, but it doesn't have like as many wrapper layers, and so you're going to do a lot more low-level work. So this is definitely not like, I wouldn't actually call it Arduino. I'd call it like you're using the Arduino like program to compile, but it's not like you can use any Arduino libraries. Like no Arduino library will work because almost every Arduino library requires a C++ compiler. However, once I got write byte and read byte working, and they work pretty well, then I was able to be like, okay, well, I want to like read an I2C register, and then I can do scan, and then I can do begin. Actually, in this case, it's using software I2C, I guess, not hardware I2C. I don't know why. Maybe it was easier to just do that. But then I was actually able to write an I2C like micro driver. And you just see instead of like wire.write, I'm using wire_write because again, I have that C function instead. But then this is what it looks like. You know, I've got this, you know, wired up this I2C sensor plugged in. I breathe on it and you see the humidity going up. There's also some basic support for NeoPixels. So hold on, I did get I got a couple quick demos going. Servo works. So let's do NeoPixel. NeoPixel, again, it's all C, and so I have to kind of rewrite all the functions over again, like the um, set pixel color, and then, the way we deal with this is that we have just one array for the LED data, and then we kind of like pulse it all out at once. But I kind of wrote like C-ish versions of all the functions people expect, like set brightness and begin. And then, you can rewrite the rainbow cycle, which does like a NeoPixel swirl. And in this case, you set the pins. So again, one thing that's a little tricky is the pin. Second, let me do the back. The pin labels for the the second version, I put them on the back because again, the board definition doesn't know like MOSI or A0. Instead, it only knows like pin P1.5 or P1.3 or P1.6, which you call it with the underscore. So in this case, the NeoPixel pin is P1.0. And then after you install the support, you just select the generic CH552 board. And then my Arduino install is like crazy slow, so it's going to take a second. I think I have like 5 bazillion libraries. And then I want CDC, USB upload, and then one thing I've noticed, you definitely have to select 16 megahertz internal 3.3. This is a 3.3, not 5-volt microcontroller. And then let's try uploading this. Let's see if this live demo works. But what is nice is it does the auto reset stuff you expect, auto upload. All right, let's see. Okay, so it it's uploading, auto reset. And then if we go to the overhead, you'll see it's doing the classic NeoPixel swirl. So things that work are, CDC output, so you get serial output. NeoPixels works, Servo works, SPI works, I2C works. But again, you have to rewrite all your drivers. So, what would this be good for? It's like, if you needed a USB interface chip that was like, you did maybe want to reprogram it, but it's okay if it's like not trivial. It has to fit within the memory capabilities of the chip. So if you go to the computer again. So oh, all right, a baby. I just demanded. Can you go to the computer real fast? Yeah, there's a baby. So there's 16K of flash, and then it looks like there's 1.25K of RAM, which is actually pretty good. You'll need that much RAM for doing USB. So like you probably lose about half of it. And you have a certain number of pins, but not all the pins are available. Because like I said, there's every package is different. The ADC is only there's only 4 channels and they're 8 bits. There is capacitive touch. I haven't tested it, to be honest. And like I said, the package I'm using is the QFN 16. It's a little rare, but it's the only one that fits so nicely. Basic top, which fits very nicely on the Cutie Pie and doesn't require a 4-layer board. So I've ordered the panels. I tested all the GPIO. I tested all those capabilities. I think this is like kind of like a funky like chip. Like I said, you're not going to beat anything else for the price. Like if you need to make something, and you want no LDO, no crystal, like no passives really needed. It's just like ready to go USB, and it can do bit twiddling. It can do, I think, HID if you use, maybe not through Arduino, but through the SDK. Although maybe you could just throw the HID code in there, because I know people have been using it with some like small keyboards, macro pads, because you could have a timer do the pin matrix muxing, or you could use expanders. And then, like I said, you have, keyboard input. So I'm not going to use this for making Trinkies, I don't think, because I like boards that can run CircuitPython or Arduino, and like I definitely want to be able to use all of my library code. But I think if somebody wanted to make like I was talking to Phil, maybe like a USB business card, and you wanted to be like 99 cents for the entire bill of materials, you could do it. You can make like, you know, $1 business card that has a USB interface by using this chip because it's just so cheap. You know what it would do, I don't know. But it is possible. But you know, to head off questions like, no, it's never going to run CircuitPython. Will it ever have a C++ compiler? Maybe, but somebody's got to find a free or open source C++ compiler that supports this chipset. It's kind of unlikely. And I'm not going to do that work, and I'm not going to do any other Arduino porting. This is mostly just, I think, a fun toy. I thought it'd be cute to have this very low-cost chip in a format that, you know, you could then use accessories. I like that, you know, you could plug in I2C devices and like do little I2C things with it, maybe little NeoPixel stuff. Anyway, so that's the that's just what I've been working on this desk. So I ordered that PCB and I got the tester design this morning. So I do want to cycle back and get to the C6. But I want, this was ready to go and very easy. So I wanted to kind of polish it off and get off my desk. I think I designed this back in like 2021. But then, the CH552 chips were like impossible to get. I do also want to next take a look at the WCH. The same company makes like a Cortex, I think M0 chip called like the CH32V00 or something, and it's also like a super low cost Cortex. Maybe I'll make a Feather or like an Itsy Bitsy or a Cutie Pie with that also, just for like the fun of like, wow, it's a 50-cent Cortex M0 that's like got everything built in. Okay, so that's what's my desk, and so let's go to the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada brings you the power of her brain to find things on digikey.com. We call this segment the Great Search. Ladyada, take it away.
Okay. Gigantic pulsing brain of searching for parts. Okay, so this we sometimes look on social media and I see like people like asking folks like, oh, how do I repair this, or where do I get something? This person actually did find an alternative to this power supply, but this is such a common issue that I've seen for people who are repairing like old synthesizers or old computers, old test equipment, or just like anything electronicsy and old that might be like kind of intense and isn't just like simple battery power. It's not that uncommon to have like crazy weird power supplies. So this is I don't know what this is. It's like Extron Super Emotia. What is this Extron Super Emotia? I guess it's a CRT gaming system. Oh, it's a max scan converter. Whoa, I don't remember this at all. Well, I like how it's like, this is the company, and they're like, you can get more information about it. So I guess it's some scan converter. Which is cool. So this older piece of equipment requires a power supply that gives it plus and minus 12 volts as well as plus 5 volts. And at like pretty high currents too, not like 300 milliamps. It's like they want 3 amps, 5 volts, 2 amps at plus 12, and then, 0.3 amps at negative 12. So you definitely could take like an ITX power supply and make a connector and design your own power supply. But and in this case, this person was recapping the power supply because the capacitors had gone bad. Looks like there was even leaking a little bit of electrolyte out there. But it's also possible to get new power supplies, even ones for these kinds of weird interfaces. So let's take a look. So first off, you always want to look at the label for all the powers and currents. So like I said, there's 3 power supply voltages: 5 volt, 12 volt, and negative 12 volt. And it needs, as you expect, because it's more than one voltage, it has a strange connector. In this case, it's a DIN connector. I don't think they showed the DIN connector, but there is a diagram, which is really nice. We need this diagram. So then let's go to ACDC power supply. Okay, couple options. Gotta hydrate. Okay, so there's ACDC converters, and these are like modules, and they have tons of them. Often these are called like mean wells. They're mounted inside of an enclosure, and they will absolutely work But they often have exposed mains wire over here, so they're definitely not safe. They're good if you're making like a device that has, you know, a power input or inlet, and you know how to handle these voltages, and you won't mess up confusing the hot and the neutral and the ground. But for mere mortals, what you really want is something that takes like an IEC plug, which these tend not to, and it again gives you that connector. So there's a you know, like this is DigiKey sell stuff for engineering and product design, so you'll be able to get little modules and stuff. But we want a wall power adapter, something that plugs into AC and gives you that voltage out. Okay, so we definitely want something in stock. So let's click in stock, which will cut down a lot of options. Next up, I don't actually care if it's active or not, because let's say we only get one. I don't care if it's like, you know, it's this is the last time buy or whatever. Like we're cool with whatever, because we're only going to get one. For voltage input, I'm not going to be picky because I'm in the US. So I don't really, you know, as long as it covers 110, and pretty much everything is going to cover 110, 112 volts, 115 volts, I'm good to go. Okay, so next we want the voltage output. This is the important part, because remember, we want +5, +12, and -12. So if you look through the list, there is separated by commas, sometimes multiple voltages, in this case 24, 5, -15, 55, 62, whatever. But up here, there is 524, -12, and then 512, -12, is what we want. Bam. And that really cuts down. There's not a lot of options. So, you know, if you couldn't find something with the exact same connector, you could still get this. You know, if you did have the outputs and the outputs at the right currents, you can always cut the connector off and then splice on your own connector. But it's worth checking if they have the connector we want. So first up, I also have to make sure that I have the current outputs necessary. In this case, I need 3 amps at 5 volts and 12 volts, 2 amps, just like quite a bit. So let's look at what's available. So it looks like there's some with this DIN and some with this weird ass rectangular connector. But they do have, you know, seven total, and they have a bunch that are the DINs. And so let me just select DIN connector. That's round connector. And next I want one that has, what was it? 5 volts, 3 amps. So if we look at the current output here, you want to match it up. So like 5 here is 4 amps output. This is 5 volts, 2.4 amps, and this one's 2. Sorry, this is 5.5, but the 12 volt is only 1.5 amps. So this one wouldn't be that good. This one would be okay because it has the right amount of current. So you could do this one, but there's only one in stock. And then this one is the one that had the right amount of current. To be honest, you might be able to get away with this one. Well, no, actually the 12 volt is also 1 amp. So you definitely need to have this one, 50 watt, because it needs to have enough current from the 5, 12, and -12. This is over spec'd, but like it's always okay to have more current capability as long as it is within the voltage range. So let's now check the connector. So meanwhile, like I mentioned, their top supplier of beefy power supplies. They're really good at it. They've been doing it for a long time. Looks like they have a lot of ones in this family, and you can select different Whipple and rated and efficiencies. But like this one's stocked, and I don't really care too much about the efficiency. And then they have the connector. Okay, so here's another thing you got to watch out for. So DIN connectors are not labeled the way you'd expect, like 1, 2, 3, 4, 5. They actually like alternate. And this is also upside down. So we want to rotate this. So I'm going to just go doot, doot. So now it's upside down, but that means, you know, you read it backwards, but at least that way, you can, matchy. So the first pin, so this leftmost pin and the bottommost pin is called return, which is ground. So pin 1 and pin 2 is in fact common ground. So that's good. And then the second pin here is -12. So that's number 4. And that is in fact a negative V out. And then the like whatever 4 o'clock pin is plus 12 volts. So that's number 5, and that's the positive voltage. And then the rightmost pin at 3 o'clock is plus 5 volts. And yeah, pin 3 is 5 volts. So yeah, this power supply will do the job quite well. So this is my pick for the Great Search.
Where in the world
Great search.
is that part I need? The Great Search with DigiKey.
All right, that's our show. We're gonna go and take care of a baby. So thanks for joining us. We'll see everybody throughout the week. We got JP show, 3D printing, show and tell, ask an engineer, Great Search,
Scott's deep dive.
deep dives, lots of videos. You name it, we got it going on. We'll see you all during the week. This week, thanks everybody.
Bye, everybody.